Hey guys, today I want to talk about higher dimensions, particularly the fourth dimension. To start off, let's first know what exactly a dimension is. Most of you must have a general idea about a dimension, but exactly, a dimension is defined as the minimum number of coordinates required to define a point on a plane. So, what does this mean? This means that basically a line is one dimensional because only one coordinate, the x coordinate, is required to define a point on it. Similarly, a square is two dimensional because just like the Cartesian plane, we need two coordinates, the x and y coordinates, to define a point on it completely. Likewise, a cube is three dimensional because we need three coordinates, the x, y, and z coordinates, to define a point on it completely. You really need to understand this concept for the topic, and to see if you got it, pause and try explaining why a point is said to be zero dimensional. Now that we have the basics cleared, let's try to think of a higher dimension. Imagine that there is a dimension higher than the third, that is, having one more axis or direction. How many coordinates do you think will be required to define a point on this space? Yup, 4. The x, y, z and the w coordinates, and this would be the fourth dimension. While the human brain cannot envision such a space, and there is not much proof proving it even exists, mathematicians have predicted a lot of behaviors of the fourth dimension, not only because it is such an interesting concept, but its existence solves a lot of mysteries in science. So, to get an idea of how the fourth dimension works, we will see the behaviors of the first, second, and third dimensions. To start, let's see how a hypercube, the 4D equivalent of a cube or a square, would be like. Now, it could be said that a point is extended in the x direction to form a line, a whole line is extended in the y direction to form a square, keeping all the angles of 90 degrees, and a square is extended in the z direction such that all sides are perpendicular to each other to form a cube. So a hypercube would be a cube extended in a fourth direction, one which we cannot even imagine, let alone see, so that all sides are perpendicular to each other again. Also, it could be said that a point has one vertex, a line has two vertices, its endpoints. We know that a square has four vertices and a cube eight. See a pattern here? These numbers are the powers of 2. So the number of vertices in a hypercube would be 2 to the fourth power, that is 16. In fact, any n-dimensional equivalent of a quadrilateral will have 2 to the nth power vertices. Secondly, we know that a line is bound by 2 points, a square by 4 lines, and a cube by 6 squares. By this, we can infer that a hypercube would be bound by 8 cubes, each face being called a cell. We all know that the net of a cube looks something like this. So we can infer that the net of a hypercube would be like this, made of 8 cubes. This 8th extended cube would meet this one by being folded through the fourth dimension, just like we do by folding squares through the third dimension to form a cube. Now, to get a closer idea about these 4D hypersolids, we will use this cube. When seen face first, a cube looks like a square. Now guess what a hypercube will look like face first? If you answered a cube, you're right. When seen edge first, a cube appears to be two joint trapeziums. This implies that a hypercube, when seen edge first, will appear like two frustums joined together. For more information on the topic, see the Wikipedia page on 4 dimensions. Another phenomenon that will help us get a closer understanding is using shadows. If you've never seen the shadow of the wireframe of a cube, try guessing what it would look like. My first guess was a square, but I was really wrong. Actually, the shadow of a cube's wireframe looks like this. A square within a square and all the corresponding corners joined. So the shadow of a hypercube's wireframe would look like a cube inside a cube and all corresponding vertices joined. By this method of analogies, we can sort of get an idea of how a 4D world would look. But it is impossible for our minds, which have experienced only 3D their whole lives, to actually get an image of a 4D object. In fact, we humans can't even see in 3D. We actually see in 2D, but using shadows can infer the 3Dness of something. That is why these are a total rip-off. And that is why illusions like this work. Mind blown, right? Mine sure was. Hope you liked the video and thought it was on point.